Hi everyone. So previously we were talking about the dot and cross diagrams of the covalent compounds. We know that covalent compounds are made by the non-metal atoms by the sharing of electrons, and we know that the sharing of electron is often represented by dots from one of the atoms and cross from the other atoms. And it totally depends on the group number, that how many bonds a certain atom makes. In today's video, we're going to largely dedicate our discussion to how these simple covalent molecules have their physical properties. So when we talk about the fact of the simple covalent molecules, we are talking about their physical properties largely. Simple covalent molecules. We remember the fact that a molecule is formed when two or more atoms, they can be the same atoms, they can be different atoms as well, but two or more atoms chemically combine together. They chemically combine together. So what happens over here is that we have these molecules which are smaller, they have fewer atoms, and they are not connected to each other with the other molecules. So each molecule is not connected to the other molecule right now. For example, if I were to talk about water molecules like these are my oxygen atoms over here, and let's suppose these are my hydrogen atoms over here. These are my hydrogen atoms. Let's label it that I have got oxygen atoms and these are hydrogen atoms. And obviously we know that each hydrogen is making one covalent bond with the oxygen atom, so each hydrogen atom has one bond with the oxygen atom, and so on and so forth. I'm drawing simple lines, single lines, to show these bonds over here. This is a water molecule, so let's label it that this is a water molecule. Each water molecule is attracted to the other water molecule through weak intermolecular forces. So these molecules have weak intermolecular forces between them. Similarly, for example, if I were to draw any other kind of structure, for example, if I were talking about nitrogen molecule, let's suppose nitrogen molecule which looks like this. So each over here is a nitrogen atom bonded with another nitrogen atom through 3 covalent bonds. Remember, nitrogen belongs to group 5, they have 3 covalent bonds between them. So these are nitrogen molecules, 2 nitrogen atoms in a diatomic state combined together. They are weak intermolecular forces over here. It's an N2 molecule. And these forces are not very strong. So these forces can be overcome really easily. For example, if I were to draw a dotted line represented by blue lines, so these are not very strong forces and they can be overcome really easily. Obviously, the extent of forces may vary from molecule to molecule, but they are often not very strong. So these are weak intermolecular forces, aka IMF. And these forces can be overcome really easily. So they can be overcome really easily. If I supply heat energy, the heat energy is going to help in overcoming the force. So the molecules can absorb heat and they can begin moving away from each other if heat is supplied. So one thing is very clear, that these forces can be overcome really easily. So what are their properties? Let's talk about their properties and the reason. Properties, reasons, or you can say explanations. These molecules have low melting and boiling points. And why is that so? Because they have weak intermolecular forces between the simple molecules, or you can say between the covalent molecules, which can be overcome through less heat. So you can say less heat is required to overcome the forces, to overcome the IMF. Obviously, F means forces. So that is why it's easier. The important word over here is that we talk about weak intermolecular forces and the fact that it's less heat is required to overcome the forces. They are generally gaseous, or you can say very few are liquids at room temperature. So generally they are gaseous or liquids at room temperature and pressure. RTP means room temperature pressure. What's the reason? Because we just mentioned that their melting point and their boiling points are generally lower than 25 degrees Celsius, which is normally the room temperature. So obviously if the melting point and boiling point are both lesser, it's gonna be a gas or liquid at room temperature. Water has a little higher boiling point, that's why it's liquid, not gas, but generally other substances are normally gaseous at room temperature. Do they conduct electricity? So my answer would be no. They are poor electric conductors. They never conduct electricity. What's the reason? Because their valence electrons are not free to move. Their valence electrons are occupied in bonding. Because they remember they were supposed to share electrons with each other. So over here they are making the bonds. So you can mention their valence electrons are occupied in covalent bonding and cannot be mobile. Thus, they are not mobile. They are not able to flow. So the keyword over here is going to be valence electrons are occupied in bonding and they are not mobile electrons. So this video largely talks about how simple covalent molecules have weak intermolecular forces between them. It's not electrostatic attraction, it's weak intermolecular forces. And that is why these molecules have less melting and boiling point, because the forces can be overcome really easily. They have normally melting and boiling points even lesser than 25 degrees Celsius. Their valence electrons are already occupied in covalent bonding, so they're not free to move. So this video helps us to remember the properties of these substances. In next video, we're going to be talking largely about the metallic bonding. So stay tuned guys. Thanks.